Topology setup here, and I've just been running some data collection and experimenting with IGMP snooping just to see what the real world behavior is on the platforms that I'm working with here. Now, what brought this I suppose piqued my interest in this was an article which I read. It's a bit of a dated article, but it states here, customer has a network, and you can see there's a pretty simple network topology here. And the problem is that it comes says, well, I have a source which sends it into a switch. The source, the multicast source and destinations are both in the same layer 2 broadcast domain. However, one of the receivers is actually on an adjacent switch. And so the problem is that, as described here, in the question that's trying to be answered is, well, why does one receiver receive traffic, but the other receiver doesn't receive traffic? And so the answer given in this article is that because the IGMP messages, and again, this presumes that there isn't, we should scratch this router out. Forget the router here. This presumes that we don't have a multicast router here. It's simply IGMP-enabled hosts with a source that's sending traffic. Again, the host, the source sending traffic, it can be IGMP-enabled or it cannot be IGMP-enabled. It doesn't matter. IGMP doesn't have anything really much to do with the actual sources being sent. It doesn't need to. IGMP doesn't have real specific requirements for sources that are sending in the traffic. The source just simply needs to send traffic. So the idea is that, of course, IGMP snooping allows us to build state information about interested receivers. Okay, so in our case here, again, this is as the article describes, is that the receivers signal using an IGMP membership report to the switch. The switch CPU intercepts this and actually is able to build state information about which ports this multicast traffic should be forwarded to in the event that it receives traffic for this group destination address. Okay, and the article goes on to describe with this particular platform, it's 6500 with SOUP 720 and a Catalyst 3750. It goes on to describe that the reason why this receiver here doesn't receive the traffic is because the switches can only maintain local state information about IGMP queries received if there's not an IGMP query / IGMP router present. So in other words, the state information cannot be built over here because IGMP queries are absorbed locally here, and there is no way to maintain group membership apart from having an IGMP query present. Okay, so now this is kind of, I suppose this is different than what I've come to understand. If you read the RC about IGMP snooping, and also what I've observed, I think this article actually is probably incorrect, and it doesn't apply to all platforms. Or more accurately, probably what happens is that the behavior has changed with newer versions of code. And the reason I say that is because I have a basic topology setup here, and what I'm seeing is that so to recap here, we have switch 1 and switch 2 with two interested receivers here, and we have multicast source here. What I am observing is that if IGMP snooping is enabled, but we don't have an IGMP query present, what I'm noticing here is that the switches actually flood this traffic. I'm assuming it's unknown multicast, and I've observed that here in the lab. So in other words, if I fire up a multicast feed, let me actually demonstrate this here. So let's show you the state information right here. Right now we have no groups. There's no IGMP query present. So let's do show IP IGMP snooping query. You see here there's no query present because we don't have a multicast router. Again, according to the article in this situation, the source here should receive this traffic. I should say, more accurately, what I should say is the switch should flood this traffic, but it should not flood it to the adjacent switch, right? And so it should never make it over here to our second host, okay? But what I observe is, and let's go ahead and fire this up. So we'll just do a ping here. Again, we've issued kind of like issued kind of a, simulating a host with the IP IGMP join group on gigabit 0.1, which is where receiver here, this receiver 2 is connected to via switch 2. Okay, so again we see here, and there's two interesting observations. A is that in fact router host 2 actually replies to this message because it sees that it's a explicitly joined this particular group. But something interesting here on switch 2, again, you'll have to excuse that. That's older information. That's from when I was testing this previously. I've since removed that configuration. If we do look at the Snooping table on switch 2, you notice that there is no state information built here. It's because, in fact, I think the article is just dated, in my opinion, and I think that we've changed its behavior. It looks as though we actually flood this traffic, because if I go over to router 1, I should say receiver 1 here, which of course is a router, I've actually have not issued the IGMP join. So here's the running config on this interface here. And so you can see here we haven't actually joined this group. But if you look at my Wireshark capture, you can see here that, in fact, we do see that this traffic, and you can see it's a little hard to see here, but you can see here that this traffic is actually being received via the fast Ethernet 01 interface. So in other words, this traffic is being flooded out here. It's being flooded out here on all ports. Okay. Again, that is with IGMP snooping enabled. I would expect this to not be the case, because by definition, IGMP snooping should constrain multicast except for ports that are explicitly enabled for it. And again, IGMP snooping is definitely enabled. And I'll actually, let me, just so you don't think I'm making this up, let's do show IP IGMP snooping. You can see here that it's enabled, and all my ports are inside VLAN 1. So it's enabled here. So like I said, I would expect this to not be the case, because IGMP snooping by definition should constrain multicast. At least IANA, the IGMP multicast range, which of course is in the 0.1.0.0.5e range, which was what we have here. Okay, but again, you can see here that that's not the case here. Okay, and so let's go ahead and actually fire up an IGMP querier. In this case here, we'll just actually make router 2. We'll make it an IGMP querier. So we'll just say IP PIM sparse mode, and I can't remember if I enabled IP multicast routing, but I'll put the commands in anyway, because I'm not sure. Okay, so now what's going to happen is I expect to see. Well, I should say I would expect to be this constraint, but what happens now is that this traffic to the port switch 1 actually now will eventually be constrained once the querier is detected, because what happens is that we detect a querier on the VLAN. I should say let me actually this might take some time to actually go into effect. But what I expect to happen, let's make sure we have it enabled too. That's the wrong interface. So we need interface gigabit 01, say IP PIM sparse mode. So what I expect to happen is eventually we're going to build state information. So okay, so now we're detecting a querier. So what will happen is that now we are able to explicitly build state information. Okay, and so in our case here, we don't have any interested parties for this particular multicast feed. So, for example, when I send this traffic here, it should actually it should be constrained here. It should switch 2 should not forward this out here anymore. But it should forward it out fast Ethernet 0. It's actually 0.2, because this port is part of that group. So let's actually look at the state information on switch 2. So show. Actually, I'll just borrow the scroll buffer here. In fact, we can see that already. We can see here that 239 group. It says it says forward this out fast Ethernet 0.2. Again, because we don't have any interested receivers on switch 2, it's not going to forward it across this link here, which is actually 0.23. Okay, and again, we observe that here. If we look at our Wireshark capture, the flow of this ping has actually stopped. It's no longer being received, and this capture is done, by the way, on the fast Ethernet 0.1 on switch 1. So it's no longer, so this traffic is constrained correctly now. Again, I would actually expect this. In my opinion, this is not expected behavior. This should not be flooded. Even if there's not query present, it should not be flooded as unknown. Okay. So now what we'll do is we'll go on router 1, and we'll actually issue. Host 1, and we'll issue the IGMP join over here. What this will do is this will issue an unsolicited IGMP membership report, send it up here, and then the switches can actually build state information. And we should now see the port for this particular group. We should now see on switch 2 fast Ethernet 023 added, and then on switch 1, 01 added to this group. So we'll go ahead and do that. Clear this off here. So we'll say, actually this is his previous configured. Make sure on interface gigabit 00. So we'll say IP IGMP join group, and then of course our group is 239.3.2.1. Okay, so now our state information should be updated on switch 2. And again, that's exactly what's happened here. So switch 2 basically said, okay, I have a receiver over here, so you need to add this to my ports that want to receive traffic for this flow. Okay, same thing on switch 1. Switch 1 has knows that there are interested parties for this group on fast Ethernet 01 and fast Ethernet 23. Okay, 023. Okay, so the forwarding behavior of switch 1 is when you receive traffic for this group destination address, I'm going to forward it out these ports. Okay. So again, the lesson learned here is that the behavior here, when we don't have a courier present, again, at least on this platform, and I want to emphasize this might be something, I don't know if it's specific to this platform I'm on, but I'm actually on 3560E with advanced IP services, and this is 12.246 SE. I don't know if this is something that's specific to this platform, and it's different on the 6500. I have no idea. But again, simply observed, as we proved with our captures, is that these adjacent switches, when switch 2 receives the multicast feed, when there's no courier present, it actually floods it as unknown multicast at all ports. Okay. As soon as we enable the courier, we see here that multicast is constrained correctly. Again, my expectation would be the opposite of that. I would actually expect, if we don't have a courier present, but IGMP Snooping is enabled, I would expect this traffic to not be forwarded to any ports, except for the local port here. Because again, according to our article that we showed, the Catalyst platform is able to actually process IGMP membership reports that are received locally, but it's not actually able to perform IGMP processing for the adjacent nodes. Okay, when there's not a multicast router or / courier present. Okay, so again, but what we proved is that that's not the case here. So what's odd is that this is the same behavior as if I disabled IGMP Snooping. So it's simply flooding of traffic, even on ports that are not interested in explicitly receiving it.